lesson today we will discuss about the tutorial 4.2 Semiconductor Diodes. Okay, this one is the answer for the objective question. From here I will discuss about the three questions. So we go through the question number 12, 14 and also 16. Okay, the others you can check by yourself. Let me discuss, go to question 12. Okay, let's see the question 12. They show about the circuit containing of the two diodes by using the transformer. So from here, transformer is using the alternating current voltage. Okay, so from here we can see about the which one following is a waveform from the CRO screen. Okay, so from here we see how the current flow through. Okay, we're going to see the first part. Okay, first part is current. We start with positive here, then they up. Okay, so this one is a cathode, anode to cathode, so they go through. So until this part, they will go to the resistance. They also will go to the CRO. Okay, when they go back, then they can go through one complete cycle. So if I draw, then should be the first cycle is okay. Okay, now I reverse. I go to opposite direction now. Okay, by using the blue color. Okay, now when I just move, okay, I move reverse. Then I go down. Then I go through the second diodes. Then I go up again. So when I pass through the R and also the CRO must be same direction. When I just go down, then I up, then I go back the same direction. So that means if I'm using a transformer, I can produce a full wave rectification by using two diodes. So continuous must be the same. So from here, this one, the answer must be the answer B. Okay, so we go to the next one. Okay, the next question, there's a 14. They show about the rectifier. Okay, they got bridge rectifier, rectification circuit using the 4 diodes and 3 resistant PQR. So I want you to focus is a P, Q and also R. Later we see the direction how to flow through these 3 resistors. Okay, which one following resistance? They only the direction current flow. That means they just one direction current flow through. So we check the first part. Okay, first part we start with the P. So P, then they go to the number 1 diodes. Then they go through the R. Okay, after the R they go up, then go here, then go through the second one, red color diodes. After that go back, pass the Q resistor, then go back. So the first direction for P is go to right, then another one is a Q go to left. Okay, now this one we produce the first cycle. So we draw first, they produce the first cycle. Okay, there's a DC current. Okay, now we go to second part. When I reverse the current, so now the direction current at the P is go to right. Then we pass through this part, then up. Then we go through number 3, third diodes. Then we go to R, go down also. Then after that we go back here. Then this part we go to the up until we go to number 4, blue diodes. Then we go back. So from here I want you to observe is a P, Q and R. Can you see the P is opposite direction? First round there's a go to right, second round they go to left. Okay, Q also the same, but you see the R. The R resistance, when the current go through, they always in the same direction. So the direction is go downwards. So from here they ask you which one resistor is only one direction. So the answer should be R. Okay, then we go to the 16. 16, there's a no diagram. You can refer here. Okay, this one is a 16 question. Transformer again, but they're using one diodes only. Then they got a capacitor. Okay, make sure you can see about the capacitor here. Okay, capacitor is a parallel with the resistance. So this one is a capacitor. Okay, now based on the circuit, which one following is a waveform they formed by the CRO. When you see they got capacitor, then we know they are keep the charge and release the charge, then make the current flow is more smooth. So from here is more smooth, that means if we draw, okay, this one is a halfway, is it? Because they're using one diodes. So this one is without the capacitor. If got capacitor, they must move. Okay, they must go draw the smooth one. Okay, so this part is a output waveform. So from here we just find the sliding lah. So we find it the answer should be A, because A got sliding part. Okay, so we just discussed about the objective 3 question. So the rest, if you got problem, then you can text me, then I will explain for you. Then we need to go is a structure question. Okay, question 18. Okay, let's check the question 18. Okay, the arrangement apparatus, they study about the conductivity of the semiconductor diodes by the student. Okay, when the switch is closed by the student, the bulb does not light up. So that means this one situation, the bulb cannot light up. So the bulb does not light up when we're using the diodes. This situation we call it as a reverse bias. Okay, remember what we learned before? So we just write this one is a citation for reverse bias. Okay, so now you see the question. In the space below, they want you to draw the diagram. Okay, for this one, the figure A. So from here, we need to draw the schematic diagram for the bulb, diodes, and the battery, and also the switch. So for this part, you must draw by reverse bias. Okay, how to draw the reverse bias? Okay, we got the situation you want to draw the reverse bias. First one, your connection. Connection for the diodes and also the battery must be reverse. So this one we can produce a reverse bias. So let's check the answer. Okay, so we're going to check. So from here, can you see this one is an anode? Okay, but terminal here is a negative. So this one is a reverse bias. So the switch is closed. The bulb does not light up. So now you can state the characteristic of the diodes cause the bulb does not light up. What characteristic for the diode can make the bulb does not light up? So the characteristic is the wrong connection, is it? So this one wrong connection, we just write reverse bias. I think they got answer already. So I just erase. Okay, they will show the answer. So there's a reverse bias. Okay, so this one is a characteristic for the diodes because you are wrong connection. Okay, number 3. Okay, now we need to state the correction. Okay, what you need to do until you can let the bulb to be light up lah. So your situation is, we got 2 situations. First one, you can say you reverse the connection of the diodes. The second one, you can say reverse the connection of the battery, terminal of the battery. So we're going to check. First one, you can mention reverse terminal of the dry cell. Okay, number 2 is reverse the connection of the diodes. So these 2, either one you do it, then the bulb can be light up. If both you do it, it's actually nothing happened. The same like the original. Okay, then we go and see the question B. Okay, question B, they show about the circuit X. Okay, circuit X, they are connected to the transformer. Okay, connected to the transformer. Okay, for the transformer, after that they got resistor R. So the resistor R here. Then after that they join with the CRO. Okay, now we're going to see the result. Okay, when the switch on open, the waveform they show. So this one result, we find it all the wave pattern is above. Okay, when you draw the center line, you find it all above. So this one actually is a direct current. Then we see it, there's one of the full wave also. Okay, full wave cycle, and also there's a direct current. So from here we need to convert, because the transformer, okay, transformer is using the AC current. So this one using AC. So later you produce should be the DC. So from here you need to draw the diagram to show how to convert the AC to DC. So remember, we must using the diode, is it? Then you want to get full wave, you must draw the bridge rectifier. Okay, let's see the answer how to draw. Okay, this one is an example for drawing. Okay, now we're going to check how the current pass through the whole bridge rectifier. Okay, example, if I start from here, so this one positive, then I start to move. So the first round, I need to find this one, number 1 diodes. Then I go until this part, I go to find R, resistance. Then I go back, red color, up again. Then I go to number 2. Okay, after that I go back. So I finish first cycle. So I can draw the first cycle lah. Now I continue for the second round. Second round, I move in opposite direction. So when I move in opposite direction, so I start from here, blue color part. Okay, after that I will go to number 3. Okay, after number 3, then I go to the R again. The R also go downwards. Then I go back to red color, then I up. Okay, from here I need to go number 4 diodes. After that I go back. So from here, the second cycle I also can be produced. Okay, second cycle also is a direct current because I refer to the R. R will join with the CRO. So from here, I will continue to get the full wave rectification. So you need to draw is this part for the bridge rectifier in the circuit X. So make sure you draw the connection must be correct. Okay, then we go to number 2. The space that below the draw the waveform to produce in the CRO screen when the capacitor is connected parallel to the resistor R. So that means you need to draw the smooth full wave rectification, the wave pattern. So from here you just add the sliding part. Okay, let's see here. Okay, so this one is a full wave rectification. After that, and also got capacitor, so they can smooth the current, or you say the voltage output. Okay, give the reason for your answer. B2, why you draw about the sliding. So from here you must say about the function of the capacitor. Okay, let's see the function for capacitor to make it become sliding. Okay, the capacitor, they release the charge into the circuit. So after that, release the charge to what? To circuit for what? To smooth the output waveform. So that's why they can produce the result as the diagram. Okay, now we go to question 19. Okay, all the important of the value we already highlight. Okay, the one to power a ticker timer and also the transistor radio. So the ticker timer require input 12 volt. Okay, after that, and the transistor radio require input voltage is a DC. So one different here is a 1 AC, another one is 1 DC. So from here the power supply from the Abu school there is a AC, 240 AC. Now the Abu, they use a transformer shown in the following diagram to power the ticker timer. Okay, so the first one, can you name the transformer is used? Okay, we go to check how to name the transformer. refer the input and output voltage. Input 240, output is a 12 volt and also DC. So this one is a step down transformer because you reduce the output voltage. Okay, number 2, give one reason why the soft iron core. Remember this word, soft iron core is used. Okay, we use a soft iron core because of there's a easy to magnetize and also demagnetize. Okay, number 3 is a calculation. The number of the turn for primary coil. So we just write out the info. Number of turn for primary is 200 turns. Calculate the number of turn in secondary. So they want to find is an S. So assume the transformer is an ideal transformer. So we just write our info. So NS over NP equal VS over VP. So from here NS we do know, is it? So VS is how many? 12. Okay, VP is a 240. So the NP is a 2000. So finally we get the answer for the NS is 100 turns. Okay, this one is the answer, 100 turns. Okay, then we continue with the B. The transformer in the figure A is not suitable to power the radio. Okay, the transformer, they're not suitable for radio. Why there's a not suitable? Okay, refer the question, radio is using DC current. So that means there's a not suitable. Then the modification you require before the radio is used. Explain why the transformer is not suitable to use. Okay, so from here you need to explain why the transformer cannot be used to on the radio. So first one, you must say transformer is provide and what current? There's an AC current. Then the radio is using the direct current. So that's not suitable. Okay, let's see the answer. Okay, because transformer, they produce alternating current while the radio is using DC current. So name the 2 electronic components that are needed to use. How to convert AC to DC? Then we know there's a diode, is it? So another thing, how to make it become smooth? So we need capacitor. So from here, the 2 important electronic you want to convert must be the diodes and also the capacitor. Okay, then we go to the last one. Okay, the last one is one of the essay question. There's a 10 marks question. Okay, now we go and see this type of the question. Okay, they show you of the J, K, L, M and also the N containing an ideal transformer. Okay, diode in the circuit are used for the purpose for rectification. Okay, they want to convert AC to DC. Okay, now we go to check. Okay, every voltage input should be the same, 240. Okay, output we do know. Then the number of turn also different. Okay, let's see the key. NP, number of turn for primary coil is NP, and S is a secondary coil. So the first part they ask about meaning. What mean by rectification? Rectification is one of the process to convert AC to DC. So that one is a meaning of the rectification. Okay, let's check here. Okay, the process of converting AC current to the DC current. Okay, now we go to apply the second question. Okay, the second question is talking about the transformer, how to work. So that means the operation of the transformer. So that means you need to explain. You need to explain one by one about the transformer. So first step, you must say what current flow through the transformer. Okay, when it flow through the transformer, then what happens? Okay, after go through what happened, then you must talking about the magnetize. After magnetize, you must say changes of the magnetic field line. Okay, when they got changes magnetic field line, finally they can produce the voltage go to the secondary coil. Okay, let's see how the operation of the principal transformer. Okay, first one, the AC current connected to primary coil. Then the current flow to the soft iron core. Okay, the second one, when they go through the soft iron core, we know they should magnetize. Okay, after that they produce, okay, this one is a keyword. Various of the magnitude and also direction. So that means when they just go through, you'll find that they produce a different and also magnitude and also direction because there's a AC. Okay, number 3. Okay, process of changing magnetic flux because you are various magnitude and also the direction. So that means we can call it as a changing magnetic flux. Okay, because of this one process of changing magnetic flux, finally induced EMF. Okay, induced EMF they produce in the secondary coil. So this one is a 4-step how to explain the working of principle of the transformer. Okay, now we go to number 3. You are asked to make a 12-volt battery charger. So the battery charger normally there's a direct current. So you need to study all the circuit here by consider for the following aspect. Okay, you need to explain is what type of transformer you need to use. Okay, remember just now from the diagram, all the VP is a 240. Okay, now you want to produce a secondary is a 12 volt. Then we know what transformer we need to use. Okay, number 2, you must talking about the ratio. Okay, that means number of turn. Okay, and number of turn of the secondary. Later you need to find what is the ratio between the primary and secondary. Okay, number 3, you must say about what type of rectification you need to produce. Last one, characteristic for the output. So we're going to see one by one. Okay, let's see table form for this question. Okay, let me start the table form. Okay, one column you must write about aspect. Okay, another part should be explanation. Okay, now we're going to see the type of transformer. Okay, before that the transformer is a 240, is it? So you want to produce 12 volt. So that means there's a step down transformer. After that, reduce the output voltage. This one is the explanation. Okay, number 2 about the ratio. Okay, remember the ratio. Okay, your output is a 12 volt, then input is a 240. So that means we need to write your ratio should be like this. Okay, after that we go to cut until the smallest. Okay, 12. So from here we get it, the ratio is, okay, 240 and 12. I get it is a 20 and also 1. 20 and also the 1. Okay, so this one is a ratio for 240 and also the 12. Okay, so that means the number of turn. The ratio of number of turn must be follow the voltage. So we just write VPVS ratio is 240 and also the 12. Okay, for the number of turn primary and secondary, the ratio also must be 20 and 1. So the reason is what? Able to produce a 12 volt output voltage. So we adjust the number of turn, then later we can produce a 12 volt of the output voltage. Okay, number 3 is a rectification. So for the rectification, sure we need the full wave, is it? So we just answer. Okay, let's see the number 3. There's a full wave form of the rectification. Okay, why you need the full wave? Okay, the full wave, that means they can make sure the AC current they can convert to DC current for every cycle. So that means we need the full wave. So that means we reduce the information loss. So all the converting every cycle we also can be converted. Last one is the characteristic of the output current. So output current must be smooth. This one is a characteristic. So it's smooth, what you need to add? There's a capacitor. So from here we just say the smooth DC of the output current. So now DC output current and also the smooth, what's the function? You want to increase the efficiency of the battery charger. That means without the current or energy loss, so the charger can be charged faster. So this one is why we need the smooth current to go through. Okay, we just finished about the explanation. Now we need to choose it. Okay, we need to choose one by one. Okay, now we got 5 of the circuit. We go to cross one by one. We see this one is not related, we just go to cross. Okay, first part we say we want a step down transformer, is it? So from here we go and see which part is not about the step down. Step down, I think the first one also step down. The second one not step down. Okay, the second one is out. This one not step down. So we don't need to see. Okay, number 2, we're talking about the ratio. The ratio must be 20 and also 1. So this one's the ratio, 20 and also 1. Okay, so from here we cut about 2, 0. Okay, this one is 20 and 1. So this one no need to see already. Cut, cut. So this one no. This one is 12.1. So this one out. Okay, now we go to this part. We cut the 0. Okay, yes, this one is a 20 and also the 1. Okay, this one also same. Okay, now we left 3 more. Okay, now you need to produce the third one is a full wave rectification. So this one just halfway. So this one also out. So we left 2 more. There's a M and also N. So you see what's the difference. This one got capacitor. This one is no. Finally, I need to choose is a circuit M. Okay. So this one, what we going to see the result. Okay, last one should be the circuit M. So just now the explanation, you just can get 8 marks only. Because you got 4 points. 4 points, then your explanation times 2, there's 8 marks. Okay, the last, number 9, you need to choose. So from here, we need to choose is a circuit M, is it? Okay, after you choose a circuit M, you need to explain all the aspects. You just copy only. So we see the result. The most suitable is a circuit M. Okay, reason, because there's a step down transformer, then the ratio is 20 and also 1, full waveform of rectification, and produce a smooth direct current of output current. Okay, we just repeat all the aspects. Then we just finish. Okay, then we're going to see the next one. Okay, now we go to the question B. Okay, question B is a circuit consisting of the transformer and also 1 ammeter for the input circuit. So the ammeter reading is a 0.5. So we jot down here 0.5 ampere. Then the output we got 2 bulb. Okay, 2 bulb with the same volt. Okay, both is the same volt because it's a parallel circuit. Okay, parallel circuit means they get the full voltage. Okay, the power for the bulb also same, 24 watts. So the first question they ask about what is the output voltage of the transformer. So the output voltage for the bulb, they just 12 volt. Okay, so this one is the answer. We don't need to do any plus. We just drop down one of the voltage only because there's a parallel, they get the full voltage. Okay, now we need to do the calculation of the transformer efficiency. Okay, efficiency, the formula is a power output over power input, then multiply with 100%. Okay, first one we know the output power. Output power for the bulb or anything, the power we no need to care about series or parallel. We just plus together. If the series, we also plus. If the parallel, we also plus. So from here, the power output here is 48. Okay, power input. Power, remember the formula is a P equal VI. So from here, the formula
we just take 240 multiply input current 0.5. Okay, 0.5. Then we multiply with 100%. Okay, from this one calculation, we get it, the answer is 40%. Okay, so this one is the answer for efficiency. Okay, so I think this one is the last question. So we just finished the topic 4.2 semiconductor. The coming soon should be the 4.3. If you anything, then you can PM me and ask about that. Okay. Okay, so the next lesson should be the 4.3 transistor. So I also will continue upload the video.